Hi, this is Mr. Gallagher, and today's lesson will be Section 2.5 in Algebra 2, Scatter Plots and Lines of Regression, and this will be video Part A. On the screen you can see we have two graphs. Both of these graphs are scatter plots. Basically what a scatter plot is a set of points that are plotted on a coordinate plane, and then we have a red line which is drawn through the points, and that's going to be called our line of regression. Some people also call it a line of best fit. Basically what this line is just a way of trying to create a linear figure through the middle of the points to best represent the direction that the points are moving in. Before we start our first example, we're going to talk about a definition. The word correlation. Correlation is the relationship between two quantities such that when one changes, the other one does. So if you look at our pictures here, we have three different examples that all relate to automobiles. For our first one, we call this a negative correlation. If you notice, the line that goes through our points has a negative slope. So if we're talking about the value of a car compared to the mileage on that car, well, as the mileage gets higher, the value of the car is going to be lower. And same, it works the other way as well. If the value of a car is very high, that probably means it's a newer car and it's going to have low mileage, whereas a lower valued car is probably going to have a lot more miles. So that's called a negative correlation. On the other end, we have what's called a positive correlation. Here we have the insurance cost of the automobile compared to the number of accidents. Well, if you don't have very many accidents, your insurance cost is probably going to be pretty low. And then as you have more accidents, they're going to charge you more for insurance. So as one gets higher, so does the other variable. We call that a positive relationship. Notice the slope of the line is positive. In our one in the middle here, there is not really a correlation. We say there's no correlation, or some people call this a zero correlation. If you compare the color of the car to the quality of the car, there's really no comparison or relationship there. It doesn't matter if you have a dark or light colored car or a red or blue car. That has nothing to do with the quality of that car. So for that reason, there's no real pattern represented by the points. We can't detect a positive or a negative relationship. Example 1. The table below shows the years of work experience and yearly income for 10 employees of Vandelay Industries. So we're going to do 4 different steps. We'll take A and B for the rest of this video, and then our second video will finish C and D. For part A, we're going to make a scatter plot, draw a line of best fit, and describe the correlation. And then we'll select two ordered pairs and use them to create a prediction equation. So for part A, make a scatter plot, draw a line of best fit, and describe the correlation. Well, we have our table, and it has the years of experience of all the employees. And then we have the income, the yearly income of all the employees. And so I'm going to create a graph. The x-axis will be my years of experience. And notice what I did with the y-axis. Instead of writing 20,000, 30,000, 40,000, I made them values of 10, 10, 20, 30, 40, 50. And I did that just for convenience so that my numbers would stay relatively small. And that's fine to do with a graph, as long as at the end of my problem I remember I did that, because when we're trying to use what we find to make predictions, it'll be important that we remember our numbers are supposed to be in thousands. So when making a scatter plot, we can think of each of these numbers as an x and a y value, and each of these 10 employees can kind of represent a point on the graph. So my first point would be 0, 20, and then 5, 30, and so on. I'll graph all 10 points. So that's the beginning of my scatter plot. I put all 10 of the points on. And then my next step is to draw a line of best fit. So I want to draw a line that I feel goes through the middle of the points as best we can. We're not going to be able to touch every point. In fact, we might not touch very many of the points at all with the line. We just want to draw a line that best represents the direction, the linear direction that the points are going in. So there's my line of best fit. And notice, with the exception of this one point right here, it really doesn't even come close to touching any of the other ones. Well, and the last thing we're going to do is describe the correlation. So remember, there were three different types of correlation: positive, negative, and no correlation. And we just look at the slope of the line to determine which one it is. And of course, this line has a positive slope, so we'll call that a positive correlation. For part B, we're going to select two ordered pairs and use them to create a prediction equation. Now, the important thing here is we're not going to pick points from my table, even though these are important points for us. The line is actually the more important thing at this point. So I want to pick 2 points that are on the line. And in fact, I'm going to pick two that are kind of at the opposite ends of the line. I'm going to pick one down here from the lower end and one from the higher end. Well, that one point is almost on the line. That's actually a pretty good point to start with, 530, even though that does end up being one of our actual data points. But you can see there's not really any other point, especially up here at this end. So I'm just going to pick a point that's on the line that I think would work pretty well. And so the point 3065, which is 3065,000, that'll be my second point that I use. And really, you could pick any 2 points. It doesn't matter. The only requirement is that they're both on the line, and then we want to have points that are on opposite sides of the line to get the truest numbers for us later on. So once I have those 2 points, I'm going to use them to create a prediction equation. Well, we've actually done this very recently. We're going to use these 2 points to find a slope and y-intercept and create an equation of a line. In fact, we're going to create the equation of that line that's on our graph. So it starts with finding the slope. And since we've done this before, you know that if you choose the two y values, and we'll call 65y2 and 30y1, we can call the two x values, 30 we'll call x2 and 5 we'll call x1, and we'll plug them into the slope formula, and then we'll simplify, and you can reduce the fraction. And for this example, we're actually not going to use the fraction 7/5. I'm going to turn it into a decimal number, 1.4. It's not always how we do it. Usually we actually would keep the fraction, but for this one, it's going to actually work a little bit better to use a decimal number. So now that I have my slope, I can take point slope form. I'll plug in my slope, and I'll also pick one of my 2 points to put in. I'm going to pick the one with the smaller numbers, 530, and I'll put them in for x1 and y1. And then little by little I'll simplify. First I have to distribute 1.4 to the x and the 5, and then I'll add 30. And then when everything's finished, I have the equation y equals 1.4x plus 23. And that's my prediction equation for my line of best fit.